Hello everyone, welcome to Civil Engineering Stuff. And in today's video lecture, we will be understanding the basic difference between water-bound macadam and wet mix macadam. Now, there is a fundamental difference between these two mixes, which is often confusing to students as well as the new engineers. Now, here I will be doing an overview of the difference that are there between water-bound macadam and wet mix macadam. I'll try to cover each and every aspect, and this is very important in case of interview as well as basic understanding about the both of the mixes. So, talking about the fundamental difference between WBM and WMM, WBM being water-bound macadam and WMM being wet mix macadam. Now, water-bound macadam is a traditional road construction method where stone aggregates are bound together using water and the stone dust, and sometimes referred to as screens. While wet mix macadam is a well planned, well executed mix that contains aggregate and the binding material that are pre-mixed in the plant and then are laid on the field at a controlled moisture. Right. So let me just show you some pics. Now, this is a image of WBM road, water-bound macadam road. Now, here what we see is we have these coarse aggregates. At first layer, these kind of coarse aggregates are laid on the road and these are compacted. All right. So once the coarse aggregates are laid, a roller compaction is done, and definitely because these are coarse aggregate, in first go the coarse aggregates are laid, so there will be voids that will be there. Now in between these voids, the fine aggregate or the screens are spread. Got it? If you can see, these are the screens, right? These kind of screens are laid in between the coarse aggregate. So, what does it include? The first stage is laying of coarse aggregate, and then compacting them, right? Second stage is laying of fine aggregates or the screens in between and the idea is to fill up those voids by these fine material. And then the third stage comes where the water is sprinkled over the layer. So as the name comes, the water bound macadam means the material is bounded with the water, with the help of water. Got it? So these are three stages in which the WBM layer is laid. While your WMM, wet mix macadam, is a more controlled, quality controlled, like the design mix, where the mixing is done in the plant. So we have a plant where the coarse aggregate and the fine aggregates are mixed at an optimum moisture content, and then these are laid on the field directly, right? So you have a very like you can compare the kind of work that has been executed. You have a very relatively undulated surface in WBM, while you get a very fine and a very good layer in the WMM, right? So this is the basic difference. You have wet mix macadam, that is the mix that is well compacted, uh, well mixed on the plant at a very controlled and a very identified moisture content. Yet we have this optimum moisture content found in the lab, and that OMC is being used. While here the layer is the water is simply sprinkled, and then through broom, if excess water is there, or like the fines that comes out are being washed, are being cleaned through with the help of brooms. All right, so that is the fundamental difference, right? So the mix design, so aggregates are laid in layers manually, and the binding material, which is stone dust, is spread over it, and then water is added in the compaction. Right, just now what we have seen and discussed. While in your wet mix macadam, the mixture is prepared with the pug mill or wet mix plant with the controlled moisture content before transportation and laying. Right, this is what we have discussed. Now talking about the gradation, what kind of aggregates are used in WBM and WMM mixes? WBM requires coarse aggregate of different sizes and stone dust as a filler material. The gradation is done manually. Very important. The gradation is done manually. While everything, this is a well graded. Your WMM is a well graded aggregate mix, with the fine fraction mixed in precise proportion. Very important. This word is very important. Precise in a plant controlled environment. So let me show you the gradation that is used for waterborne macadam. So here, if you see here, we have a size of aggregate ranging from 90 mm to 45 mm. So we arrange these sieves. First batch of aggregate will be this. For this batch of aggregate, we will arrange the sieves in this order, and this is the gradation that we should have. Second batch of aggregate will be of size ranging from 63 mm to 45 mm. Then we will arrange the sieves in this, and this is the size of aggregate that should be there. Third set will be 53 mm to 22.4, and this is the size of aggregate. So this is the gradation, like the batch of aggregate that we can use: grade 1, grade 2, grade 3. And if we are using grade 1, this is the size of course aggregate. If we are using grade 2, this is the size of course aggregate. If we are using grade 3, this is the size of course aggregate, and this is the gradation that we have to follow. This is either of the course aggregate, either of the three grades we have to take up. So once we are satisfied with the gradation, this size of aggregates will be laid. Then we choose these fine aggregates or the stone dust. So for 30.2, we have to verify if this is the gradation that the fine material is lying. So for that, suppose we have 13.2 mm material, what we will do, we will arrange the sieves in this order, and we will ensure that this is the gradation that we are getting. Likewise, for 11.2, if we are using, this is the sieve size that we are going to arrange and see if our gradation is abiding to this, right? So coarse aggregate with either of two, like we can use grade 2, and we can go for A and B respectively, whichever type of material is available, right? Sometimes it may happen that material that is available to us is somewhat loose, maybe because of loose upgrade or whatever the case may be. So in that case, we also use binding material, right? We also use a binding material in WMM case, right? WBM case, right? So we use a binding material. So first layer will be like of the coarse aggregate, second layer will be of the fine aggregates or the stone dust, and then thirdly the binding material is added, right? So firstly coarse aggregate will be laid over this, the fine aggregate will be sprinkled, water will be poured, and then the next is the binding material, then again it will be poured, right? And then it mix this compaction in the presence of moisture is done, that is sprinkled manually or through machine. Talking about the wet mix macadam, unlike your WBM, we have only one single gradation, right? We have one single gradation, and this is the overall gradation of the material that it should be coming out, right? So what we have is we combine the aggregates, like we have a different size of aggregate. We combine them to achieve this gradation. The material should be in between this, and if you see 675 macrons, so a special note is there that the fraction passing 75 macron sieve shall not be greater than two-third of the fraction passing to 600 macron sieve, right? So less amount of 75 macron should be there with respect to the 600 micron material. Okay. Now, execution and construction methodology is the difference between execution methodology is that WBM is more or less done manually, while well compaction through roller compaction and is done in wet mix macadam, right? Like the materials are laid manually, and then roller is applied, and then fines are spread, and then water is spread, then binding material if required is spread, then water is spread. So that is done using roller compactor, right? While we have a more sophisticated paver machines are used for the wet mix macadam laying out. Talking about the thickness of WBM can range from 75 to 100 mm, 100 mm for grade 1, right? For grade 1, while 75 mm for grade 2 and 3 course aggregate that we have discussed so far, right? In general. And wet mix macadam can be laid in between 75 mm to 250 mm, right? Your water-bound macadam requires large amount of water. Like there's no like though definitely there's a quality control over the quantity of water that you need to spray, because you do not want the stone dust. You do not want the stone dust to turn into slurry, right? The You do not want it to be turned into slurry. The idea is that the water should be added in such a way that it should it should help in binding, right? Not in the formation of slurry. But there is no specific optimum moisture content determination per se. While in your wet mix megadam, we have full quality control, right? So we specify how much, what is the OMC value that need to be taken, and how this work need to be executed. So relatively less water wastage is there, more quality control is there in wet mix megadam than your WBM. Uh, for in terms of rolling and compacting, this should not be there. It should be rolling and compacting. In terms of your rolling and compacting, in terms of your rolling and compacting, heavy rolling with the proper wetting and compaction is required, and in wet mix macadam, better compaction is there, and high strength is achieved with respect to your WBM, right? Then talking about the speed of construction, your WBM is a slow, relatively I'm talking in respect, right? So WBM is a slow process, and why it is slow? Because compaction is done manually. Like I said, first of all, you will lay a layer of coarse aggregate, right? You will lay a layer of coarse aggregate, then you will compact it through a roller compactor, then you will spread fines, and you will ensure that the fines occupy the voids that are there in between the coarse aggregate, right? And then again the compaction will be done, again the second layer of compaction will be done, and then you will sprinkle water, so that binding between coarse aggregate and fine aggregate is there, and then again a layer of compaction maybe or will be done, right? So this overall takes a is a very time consuming process, while in wet mix macadam you have a very faster execution of execution, as in the plant the material is pre-mixed, right? You formulate the gradation, you add the bending fine aggregates and everything at the optimum moisture content level, you mix it in the plant, all the things is done in the mixing plant, and then you simply take it to the field, you lay the material and you compact it with a paper compactor. Done. Which code is used for WBM? We have, if you're referring north, we have section 404, and IRC code IRC 19 is referred for WBM, while for wet mix macadam, we have MOS section 406 is referred, and IRC 109 2015 used for the wet mix macadam. Now, where do we use these WBM and WMM mixes? For low volume constructions, we go for WMM road, and where the mechanical mixing is not possible, then again we go for WBM. And if we are going for somewhat economical, we are looking more towards the economical cost of construction, or where the traffic is, like I said, low volume road, where traffic is very less, we can go for the WBM. In wet mix macadam, where high traffic is there, then we go for a wet mix macadam. We are looking for a longer maintenance period, longer period of lifespan of the layer, then we go for the WM. And definitely, if we are going for more durability, then again we go for the wet mix macadam. Talking about the durability and the performance, now I think you must have grasped the overall gist. WBM is less durable. Why it is less durable? Because the quality control is relatively less, and you can very well assume that you have this coarse aggregate, and in between this coarse aggregate layer, we have the fine aggregate material, right? And as in when suppose rain happens or some seepage of water is there, right? So the chances are that these fines may come out. First thing is that. Then during the execution phase, though the codes specify the quality control that need to be done, but sometimes because there is no expert that is involved, because everything is done manually. So what happens is, as in when the water is being mixed, sometimes excess quantity of water can be mixed, or like brooming, excess of the fines need to be removed through brooming, brooming the excess of fines that are there, that need to be removed. So in that, some uh, lack of quality control could be there during execution phase. Sometimes what happens is that, suppose you have a layer of coarse aggregate. Now what happens is the fine aggregates are dumped at one spot, and from there the spreading is done. So because of which some places may have higher quantity of fines, with respect to the other places. So because of this lack of quality controls, this raveling and the damaging, this what WBM layer is more prone to. While this is not there in WMM, because we have high quality control, and like everything is well monitored, well executed, so you get a more durable payments, right? And the wet mix macadam has a very high load bearing capacity compared to the WBM. And now talking about the cost comparison, definitely WBM have very low initial cost, but because of the lesser durability, the maintenance cost becomes an issue. While in wet mix macadam, you have high initial cost, but because the quality control is so good, the in a longer run it has less maintenance, which proves to be economical in a longer run. Um, Talking about the climate adaptability to the climatic conditions, waterbound macadam do not are not that adaptable, because of which not suitable in high rainy areas. However, this is not the case with WMM, and this can be used in the all of the conditions. All right. Bonding. Talking about the bonding more, like your WMM provides better interlocking compared to the WMM. Right. So this was all about the difference between WMM and WBM. These points are very important in terms of your interview and the basic understanding. Definitely go through. I hope through this video, the clarity must have been there regarding what is the difference, fundamental difference between WMM and WBM. I hope the video was useful to you. If so, like the video, share your views in the comment section, and if you like the video, do subscribe to the channel for more videos like this. Thank you for watching. Have a nice day.